Okay, so for this next problem here, we have, again, some information. In this case, we're given information in a table. We're also given some information that says it's twice differentiable. So that's very important because twice differentiable means that the function is smooth and continuous, but also the derivative is smooth and continuous. Okay, it also says it's strictly increasing function. And then we have these values given in a table. So which of the following must be true? F has no critical points. Well, being a strictly increasing function, okay, it's going to mean that f prime is always positive. That means that f prime of x is not equal to 0. So we're not going to have any critical points. So this is true. Okay. For part B here, it says that f prime equals h for some value of c between -1 and 5. Well, that's alluding to the mean value theorem. Okay, so I'm going to just check the mean value theorem and check the average slope. The average slope is going to be between -1 and 5 is going to be 18 minus -30 over 5 minus -1. So that's going to be 48 over 6, or a slope of 8. Okay, so since this is smooth and continuous, okay, so I don't know if it's concave up or concave down, but at this point, but I know it's going up, and we know that the average slope between those 2 points must happen somewhere in the interval. Okay, so I'm just going to maybe draw that a little bit more accentuated. Okay, so there's my average slope, and I know my instantaneous slope, which is f prime. Okay, it must happen in that interval between -1 and 5. So this is true. Okay, this is true because it is smooth and continuous, and so by the mean value theorem, okay, f prime of c must equal the average slope. And I'll write that as, how did we write that before? F of b minus f of a over b minus a. Okay, so that is the mean value theorem, and that's true based on this mean value theorem because it is continuous, smooth and continuous, not just continuous, but smooth and continuous. For C, it says that f double prime is less than 0 for values of -1 to 5. Okay, well, we can check this because we know that there is this secant line here, and do the points lie above that secant line or below that secant line? Okay, so we can just check this and test. So we can just test the slopes, in fact, between, for example, -1 and 0. Okay, so slope between -1 and 0 is going to be -2 minus -30 over 0 minus -1. So I'm going to end up with a slope here of 28 over 1. Okay, so what that means is that at this point, we know it's sloping up, okay, relative to that average slope. So that means that at some point, it's got to curve back down, which means it's concave up. Or sorry, concave down. So we can say that this is also true, okay, because we can test the points here.